Welcome to the North Houston Space Society June meeting. So I'm Nathan Price. You can reach me at nathan.price@northhoustonspace.org. And I work for a software company, but I graduated from the University of Houston with a degree in mathematics. President of North Houston Space Society, volunteer at the Space Center Houston once a month. And so really passionate about space and glad to have other people that are also interested in space here at the meeting as well. So the agenda for today has got a few opening remarks, and then we'll have Greg give us an update on the latest space news. It seems like every meeting we have more and more things to discuss. The 2020s, I think, are going to be a really pivotal time for space exploration, and really have to be so much to keep up on. And then we're going to have Masa talk about the Sasakawa International Center for Space Architecture program at the University of Houston. We'll have some time for questions and answers and comments after that. And then towards the end of the meeting, love to hear about some of your personal space experiences since the last meeting. Maybe you saw a rocket launch, maybe you attended a astronomical society meeting or went to go visit someplace or doing some research. I'd like to hear what you're doing. And then at 4 o'clock, we'll end the meeting. And anyway, so pretty much humanity kind of has two choices. One, it could forever remain Earth-centered. Earth is a very special place for us. It's where all humans live that we know about, but it's also a very small speck in the gigantic universe. And it's even a small speck when it comes to the solar system. So I could see a day when our technology and our kind of vision and our capabilities extend well beyond the Earth, and we have, um, people living on the moon, and we're using the resources of the moon. We have people on Mars, we have people in orbit, we have people in Titan, and maybe we even have these generation ships that are traveling to other star systems and spreading life and civilization throughout the universe. And given a choice of just only being on Earth versus being on Earth and every place else, seems like the second choice will be way more exciting. And that's the future that I'm uh, really excited about promoting, and I hope y'all are too. And that's really the vision of the National Space Society, of which the North Houston Space Society is a chapter. And that's people living and working in thriving communities beyond the Earth, and also using the vast resources of space for the dramatic betterment of humanity. I mean, one kind of key point is that such a small percentage of the sun's energy actually falls on the Earth's surface. I mean, it's in the order of billions of times more energy is actually radiating in other directions in space. You can see at some point humanity being able to capture more of that energy. And once we figure out that technology and a way to do that economically, perhaps energy becomes essentially unlimited, and energy is required for so many of our activities. That's just one thought. But then you might be wondering, those seem kind of big, grandiose things, and we're just an organization that meets once a month with guest speakers, and occasionally we go out and visit places. But I think the North Houston Space Society can play a small part in this, and the way I see it working is by educating the people in North Houston about what's going on in space, kind of opening their eyes and um, expanding their vision about all the things that are happening in terms of research in orbit and satellite communication and the developments on the moon and Mars and beyond, and to really inspire the idea that humanity can go forth into the universe, and it's only limited by the uh, by itself, essentially. And I kind of encourage those people who might want to go get a job in space or invest in space or um, do other space related activities and kind of connect us to each other and us to people in industry and people that can um, you know, help us do more. So if you're interested in joining, please come to northhoustonspace.org. You can sign up for an email list. You can join the National Space Society. And this will give you a chance to connect with others that share the vision of humanity, kind of branching beyond the Earth. And we can all work together to educate and inspire our communities about the benefits to humanity. So I just want to let you know that this meeting is going to be recorded and posted on YouTube, northhoustonspace.org, Facebook, and other places. And you could turn on your video by, in the bottom left-hand side, there's a place where you can start the video. And you can also mute and unmute. At various times, you may take away this capability to mute and unmute just so that we have a less disruptions and distractions from the speaker. But other times, I really encourage you to participate in our meeting, and actually not just our meeting, but your meeting. And then there's the chat feature, which it looks like somebody's already using. So see you, Vito. Thanks for coming. And you can also, at some point in the meeting, we'll have questions and answers. And in order to kind of facilitate a more streamlined approach where we're not talking over each other, you can use the little feature of reactions and raise your hand. And then that actually put people in the order that they raise their hands. And I can call on you and have you ask your question. And that way we could kind of fit as many people in as possible. So that's how to use the Zoom room. With that, I'd like to introduce Dr. Greg Stanley. He's retired, but he creates and develops and manages innovative technologies, especially based on artificial intelligence. And he has a PhD in chemical engineering from Northwestern University, BS in chemical engineering from Purdue University. He has published over 25 peer-reviewed technical papers. Have a son that's trying to get a peer review paper done, and I'm starting to get a glimpse of how much work that is. So to do 25, it's really a great accomplishment. He worked at and on projects for a variety of companies, including Exxon, Gensim, AT&T, Intelsat, Biosphere 2. If you haven't done so, you should definitely go out and visit Biosphere 2. It's kind of an amazing facility. A Japanese nuclear industry government consortium, Integration Objects, and BMC. And he is the vice president of the North Houston Space Society. And with that, I'd like to turn it over to Greg.
Okay, thank you. Get my overheads up here. Okay, so I'm going to cover the space news as of today, June 5th. These initial pictures here highlight the Chinese Mars expedition. So we'll lead off with that. Tianwen-1 is the name of that. You know, they had been orbiting for a while. Now the lander has arrived and disgorged its rover. It went to a big open plain called Utopia Planitia. They picked that partially because there aren't too many rocks there, and partially because there's a lot of evidence of having subsurface water there in a frozen form, and maybe other interesting things. So it was a good place to land for them. So after they dropped off the lander and rover, the orbiter did continue its mission. So it's relaying the data back to Earth. The rover is called Zhurong, and this makes them the second country to succeed in putting a working rover onto Mars, obviously to the US being one. The Russians had tried and only lasted a minute or so. The rover is a little smaller than the US one. It comes in at 529 pounds. The US one's about 2,200 pounds. Pretty similar heights. The speed is about the same, or I should say the top speed is about the same. I don't know how much autonomy they have in their own driving, but a big factor in allowing faster exploration on the US version of this was having very autonomous driving. This is a 6-wheeled vehicle, also like the US one. It is solar powered, unlike the US one, which is powered by plutonium. Which has some good and bad points. Of course, it takes less weight, to get solar cells to Mars. The bad thing is that solar cells on Mars have problems with the dust in particular. We almost had the demise of the InSight lander that the US had put down a couple of years ago. It looks like, excuse me, it looks like they have succeeded in getting rid of some of that dust. But the dust is a constant problem for solar power there. In terms of instrumentation, it's pretty similar to what's available on the US one that's there now. They have 3D cameras, subsurface radar for picking up information about ice and other underground structures. They have composition analyzers, including the laser zapping kind of technique that we're using. The Chinese actually got a lot of help from the European Space Agency, French and Italians in particular, on some of the instrumentation that they're using on this. And they're all including a magnetic field monitors and a weather station. And that makes it pretty comparable in a lot of ways to the US current rover that's there for both of them. Their design life is just 90 days, but of course, like everybody else, they hope it'll go on for years, just like ours have. So the pictures that are shown here, the color picture in the lower left, that was pretty much the first one they sent back after they opened up the solar cells. They kind of folded out like a butterfly. You can see the on the left-hand side of that picture, one of those solar cell arrays. They also had some black and white photos up here showing the rover from the top of the lander looking down the landing ramp. And then after they went down the ramp onto the surface, they took a picture back. So it gives you an idea of what that looked like. As for the US efforts, of course, we reported on this before. There's the Perseverance rover, which also included the Ingenuity helicopter on Mars. And as to where that stands, the helicopter has made significant new records. They flew a 5th and a 6th flight. We only talked about the first 4 as of the last meeting. They flew at the maximum possible altitude, which is about 33 feet. And that's the limit of the laser altimeter that they use. They don't want to go above that because they wouldn't be able to tell their height at that point, or at least that's the stated limits of that instrument. They've now set the record for the length flown. The longest flight was the 6th one. It went about 700 feet. And also the flight lasted 140 seconds. The design flight time for this helicopter was stated as 90 seconds. So they've clearly exceeded that by quite a bit. They also went faster than they ever had before. They flew about 9 miles an hour. Now we had reported, they had previously said that the top limit was 8 miles per hour. And that was limited really based on their ability to analyze the photos they use for navigation. They use an inertial navigation system. You know, what that is starting with a known position and orientation, just by measuring forces that you experience on a gyroscope and accelerometers, you can pretty much estimate, you know, your new position without any other sensor data. But the problem is errors build up over time, so you need to correct that. And on Earth, you can use GPS. They don't have GPS on Mars. So instead, they decided to go for a visual approach. They're just analyzing photos. So they take the photos, and the photos cover enough ground that you can predict, if you think you know your current position and the velocity and acceleration of where you're going, you can predict where you should end up at the next time you take a picture. And that's all within that same photo. So they can kind of establish a series of known points as they go along, which is kind of like the way surveying works on Earth right now. The British collected data all over the universe, all over the Earth, simply by taking known points and then going out there with their relatively primitive surveying equipment and establishing distance and angles from previous points. One thing they've done on this mission quite a bit is to collect stereo color imagery. That is really to support the role as being a scout. They've already proved that you can fly a helicopter on Mars. So the real issue now is, does it make sense to use it to scout ahead and look for places where it'd be a really good place for the rover to go, what path it should take, and so on. They did have a glitch on this one. This is the first time they had any kind of glitch at all. Midway through the flight, one of the navigation images they took disappeared. So that threw things off. I would call this an actual software bug. What happened was, when they missed one picture, that they threw off all the timestamps on the subsequent images. And the problem with that is that They didn't realize it, of course. So what happened is that they ended up overcorrecting. They kept thinking they were out of position when they really weren't. And as a result, the craft itself has to tip, because if you're trying to go in a horizontal or horizontal direction, the way you do that in a helicopter is you have to tip it. So the thing is constantly tipping itself. So okay, I got a bunch of noise here all of a sudden. Anyway, they got oscillations up to about 20 degrees of pitch and roll. And they ended up landing the thing all right and went about 16 feet short of where they wanted to go. And that was close enough. I summarize that here as saying the safety system kicked in, but there's really several things that went right with this. First of all, when they designed the control system, they designed it with enough stability margin that they made sure that it could handle certain errors, and actually being off by 20 degrees didn't seem to hurt it that much. And the second thing is that as you actually start to land, you stop paying attention to those navigation pictures. And so the final landing didn't depend on the problem anyway. And as a result, they could land safely. As for where they are, we have this map of where's Perseverance, and now they've added where the helicopter is as well. So we look up here at the landing site. They landed up here where I'm circling right now. If you look hard, there's blue dots showing the original airfield for the helicopter. Anyway, the rover is starting now. It was moving around. It was off at a safe distance to watch the initial helicopter testing. But now it's really getting going on its own mission to move to a different area to start taking samples. So it's in progress. It's heading roughly south. And notice where the current helicopter position is. It's way ahead of where the rover is. So that's showing that it really can be used in a kind of a scouting capability. Back here on Earth, Virgin Galactic, they've done their first space flight test in 2 years. And this craft is called the VSS Unity. And it's really the second in a series that they generally call Spaceship 2. These are all suborbital space planes. And this is the third test of that type. And although it's a test, they did get some massive funding for some research payloads. So they're making a little bit of money in the process of doing this. But anyway, the way this works is they have this craft you see here on the left-hand side. They have a big carrier, which is kind of like two planes welded together. And in the middle, it carries the spacecraft. And here, this picture shows just after they dropped the spacecraft and the rockets are started up. And then that's a view, a more general view from above, an artist's conception. So anyway, they took off. They went up to 55 miles. And I should have said they released the craft at 44,000 feet. Anyway, they went up to 55 miles. And then they just glided back down and landed on a runway at the spaceport in New Mexico. And that sets some records right there, because that makes them the first humans launched from New Mexico into space. Now, there's a question of, well, what is space exactly? Traditionally, we've usually heard there's 100 kilometers or 62 miles. I'll talk about that in the next slide. So that one may be a little bit questionable. Anyway, commercial launches are still expected, maybe as early as this year. And their launches would have 6 passengers with 2 pilots and 6 passengers. So they have 3 more tests coming before they do that final commercial activity, though. The next one will have 4 passengers, and then they'll have a flight that will have Richard Branson on it, the head Virgin Galactic guy. And then for some reason, the Italian Air Force has signed up for the next set of seats. I don't know why, but they did. The company supposedly has 600 reservations for tickets, and these are being sold for between $200,000 and $250,000. So it's a pretty substantial price. They seem to think they have a market for it. So you can bet that they're going to pick up their efforts and get moving as fast as they can here. So where did that space starts at 100 kilometers come from? It turns out there is actually some physical basis for it, which is what that was supposed to be. It's named after Theodor von Karman, who's pretty famous in aeronautical engineering in particular. And he came up with this by calculating that near this altitude, the atmosphere basically becomes too thin to support aerodynamic flight. So you can fly an aircraft down in where the air is thick, and you can get lift by the proper shaping on the wing. As you go higher and higher, there's just not enough air, and at some point you can't even support aerodynamic flight. Now, interestingly, some other people apparently kind of rounded that up because his original calculations were not actually up as high as 100 kilometers, but it kind of got rounded. So we would say, well, it's near this area. Some more recent calculations have been done suggesting that actually 84 kilometers would be about right, which is 52 miles. And that actually apparently is pretty close to Von Karman's original estimates. There are some other things that go on in the atmosphere in this region as well. For instance, there's a very rapid increase in the temperature as you drop down below 100 kilometers. It really tends to heat up. There are some people that care about this boundary, the so-called boundary of space. One is it's called the World Air Sports Federation in English. It's actually abbreviated FAI for it's in French. That's used when they want to say, well, okay, how many astronauts have been there and so on. But it really has more than just a sports kind of an issue. It may get involved in treaties. I mean, for instance, you think about countries like the US, China, and Russia, we take our airspace very seriously. And when people fly over it, I mean, we reserve the right to shoot them down. So it kind of matters just where those altitudes are. And I forgot to mention one other thing that also defines this region of space on the boundary is that 80 kilometers, that's about the lowest that a satellite can go and still complete an orbit. So that's even in an elliptical orbit where, you know, it only comes in and is briefly at that low altitude. But any lower in altitude, and what happens is the air friction just overcomes it. It won't make it a full revolution. And that may be why the Air Force actually had picked a number close to that as well. Some of the early flights, like the X-15 rocket planes, they were really around more that 50-mile kind of range. And so we've actually given people badges saying they've been into space. The Air Force has done that quite a bit. So there's still an argument going on as where does space start? Obviously, it's somewhat of an arbitrary line, but there are some physical principles involved. One is aerodynamic lift. Two is ability to have a satellite in orbit without just crashing due to air friction, and three, temperature changes. So there's at least three different reasons for establishing a boundary in that general area. Okay, now we get fairly quickly to how many launches have there been since the last meeting? And remember, these are only the launches that attempt to go as high as orbit or beyond. So that rules out the Virgin Galactic one, for instance, which, you know, that's only suborbital. They're not intending to make a full orbit. So if people want to try to vote on this, we'll let you vote for a few minutes here, and we'll give you the results. Okay, I'm not seeing any votes. Maybe I have a problem with my. I'm going to skip that. Anyway, the right answer is 11. And I'll highlight a couple of interesting things on that. The first one is that, well, SpaceX has been very busy with their Starlink. They've now, in this last period, they put up 4 different batches of satellites, and that's about 60 satellites each time. One of those launches happened to have a couple of small rideshare satellites, so they didn't quite do 60 on every single one, but still that's 238 satellites in 4 launches in 1 month. Pretty impressive. Another interesting one is I'll move down here toward the bottom, the second Chinese launch toward their new space station. Remember, they had launched the initial modules they put up there last month, and in fact, then they had problems with the ship kind of crashing to Earth. Luckily, it fell down in the ocean, didn't hurt anybody. That one's unmanned. It's just basically putting up crew supplies and so on, but it did actually dock automatically. So now that space station is bigger now that module has been added. Another one I'll point out is that OneWeb, which is another internet service company, they now have 218 satellites up there because they launched a bunch of them on the Soyuz, the Russian rocket, to get that up there. Remember, that company is actually currently jointly owned by the UK and a private Indian company. And that's I think that's all really of major interest here. Other than, the last comment, there was a resupply mission to the space station on a Falcon 9 using the cargo Dragon, which has been redesigned to be a little bit bigger. An interesting highlight on that one is that they use a new booster for that. And that was the first one this year. And that's out of 17 launches. So it used to be that every single rocket ship, including boosters, every piece of the rocket ship, including boosters, was brand new and just thrown away. Now it's kind of gone the other way, and it makes news when you actually have a new booster being put into service.
Greg, one thing is the actual voting did come up. We had 10 people voted, and people
Oh,
are
yeah.
getting very good about the guessing. We had one person get it right on the 11, and 3 for 10, and 2 for 9. So, and then
Oh,
everybody
very
else
good.
below that. So,
Well, I guess, a hint is that quite often around 10 or 11 is a pretty good guess. It seems like,
someday,
it may pick up later this year though. So that may be, those numbers might start to get to be low. There was a period there where things slowed down because of COVID-19, and that's gone now almost, at least among us anyway.
well, and if SpaceX is even half as successful with the Starship as they want to be, it might be in the thousands at some point.
Yeah. Okay, any other discussion items or questions?
I have a question.
Yes.
The great majority were satellite launchings. Is that business as usual, just to upgrade all the satellites?
Yeah, is that business as usual? Yeah, I would say that's pretty much, I mean, that is still the biggest single customer of launches is satellites of all types. Now that includes, internet service, now with Starlink, but really it traditionally always included commercial and government use of, observation. They call them Earth observation satellites. In the old days, you call them spy satellites, but it's really not spying necessarily. It's everything from estimating growths of forests to, monitoring forest fires for that matter.
Greg, do you think that the rise in the number of customers for all these sites like Facebook and that, do you think that's driving this rash of satellite launches, or is it the reverse? Do they launch the satellites and hoping to get more clientele?
Well, yeah, I'd say it's more the latter. I mean, SpaceX, it was pretty clear. The launch, as a launch business, the total, revenue from that isn't really all that great. And that by itself, for instance, Elon Musk will never be able to get to Mars because he wouldn't be able to grow the company fast enough. So he decided just to speed the business up, he would launch his own his internet service. That is probably going to generate 10 times as much revenue as the launch business itself. But of course, then again, that overlaps because he's generating his own launch business. It was kind of handy because it also gave him a chance to prove to everybody that you can, use reusable rockets and boosters, and they were willing to put their own satellites on the line to show it. So basically, everybody assumes the business will materialize. I mean, there was no guarantee that would be the case. Iridium years and years ago was going to do the same thing. They said, let's put up satellites and we'll have internet service all over the whole world and everybody will use it. Well, it turned out everybody didn't use it, mainly because the cell system got so much better, so much faster than anyone expected. They didn't need satellite service except as a niche market, in really remote places like Antarctica or out in the middle of the ocean, or for spies, those kind of things. So I would say people are definitely building it ahead, assuming that the demand will be there. And by advertising that they have it, they're trying to create that demand. Any other comments or questions? Okay, I guess I'll move on to introduce the speaker. Masa Esmondabali. She's going to talk about the Sasakawa International Center for Space Architecture. And what is that? Well, it's a very unique research, design, and teaching organization associated with the University of Houston. Founded in '87 by an endowment from a Japanese shipping magnate named Ryuichi Sasakawa. And their mission is to plan and implement programs to advance peaceful and beneficial uses of space and space technology. So they are a leader in space architecture. The speaker, Masa, she has been involved in this and she is a graduate of that program. She started off as originally as an architect herself, but she's gone off and gotten very involved in designing habitats and greenhouses in several different space environments. Mars, with its low G, Moon with a super low G, and zero G environments of orbit. And she's published quite a few papers worth looking at. They're kind of interesting, covering, again, these different areas, and also even looking at some traditional structures and how they might apply to use in space as well. On the AIA, which is Aeronautics and Astronautics Engineering Organization, she is on the Space Architecture Technical Committee, and she's also gotten involved a little bit in. She's in mission support now for the Mars Society's project for their Mars Desert Research Station. This is a kind of a simulated Mars environment in the Utah desert. She has 10 years of experience as an architect, as a project manager, and assistant professor. And she has done work, for instance, locally for a traditional architectural company called Allraj Architects here in Houston. She is on the board of directors of the Space Society, and she has master's degrees in architecture, architectural engineering, and in particular in aerospace architecture through the SICSA, the Sasakawa Center. So with that, I'll turn it over to Masa.
Thank you for the great introduction, Greg. It's great to be here. Let me start sharing my screen. Yeah, as you said, SICSA is the abbreviation for Sasakawa International Center for Space Architecture. And as you mentioned, there's a long history about SICSA, and it was established in 1987. You can see the picture of the founders on the left. It's Guillermo Trotti, and on the right is Larry Bill, and the gentleman in the middle is the actual Mr. Sasakawa, who was actually one of the founders. And if it was because of his investment in the program, it really couldn't be happened, and we couldn't be here in the program. And these are some very, very old pictures from that time that I'm sharing with you. On the right, you can see Buzz Aldrin is talking with SICSA students about the projects that they have. This is a very, very brief history, and I wanted to show you this. This would be interesting and very general idea.
You might need to share out the sound.
Sorry, what should I do, Nathan?
Oh, I think there's a way to share out the sound. We can't hear it.
Let me see. Do you have it? Oh,
If that doesn't work, use captions.
Captions, yeah, that might be a good idea. There's the little
Can you hear
CC
it
button.
now? Can you hear it now?
No.
No.
But we can read it.
I know it is. Now? Can
It's
you hear it
paused.
now?
No. But we could read it. The closed captioning was a good suggestion.
Oh. Can you hear me?
I can hear you.
Okay. Oh, sorry. It should play the sound of the video now.
So maybe you can lip sync.
Still no voice?
No voice. I think on the sharing screen option, there's a thing that says share sound as well.
Mm. Because let me switch it to this.
Now we can hear it.
Okay, perfect.
Combination of architectural approach to design and design process with engineering technicality.
You know, we don't do wallpaper. Space architecture is the logic that makes all these things comprehensible.
We look forward to having many more students interested in the opportunity to design integrated systems around people. You have your engineers, your architectural designers, your human factors people. It's very much like a small company when you bring together these engineers who come out with design habitats, not just parts of systems, but a fully designed habitat.
Our students are, in every regard, full professionals. Houston naturally is the astronauts.
We hope to supply them with skilled graduates that have a systems engineering level understanding of the whole architecture, not just the design and the engineering.
What we do is not the kind of linear learning sort of thing. It's the kind of interactive. Let's pick a big challenging project to solve, and let's work together and do it and solve it.
And it's all about space exploration and working with habitats for people.
SICSA, University of Houston is a very strong voice to encourage and to contribute.
So can you hear me well? Because there are a couple of more videos and I don't want to switch to my microphone.
Yes, I can hear you okay.
Okay, perfect. So in this picture, Larry Bell and Guillermo Trotti, that is the very first project at SICSA, which is lunar habitat model. I mean, as I said, it's about around 80s, and they're proposing everything with actual models, and they're not, I mean, it's not really computer time. So they're really actually building everything, and they're proposing that is one of the very first one, and it's a very fantastic project. SICSA has lots of sponsors and collaborators, and you can see here that we're working with Boeing, we're Houston Spaceport, NASA, Lund University, which is in Sweden, and multiple other universities, IELTS Dover, and State University from Moscow. We usually have visitors from here, and SICSA students visit there too. It's a really great educational collaborations. So I wanted to introduce, I have categorized the project in different, based on the location. So we'll start with the ones in the orbit. As you're familiar, we have ISS in the orbit for a long time, and that has inspired lots of space architects, engineers, and everyone that what can the next space station look like. And this is one of the projects by Timothy Bishop, and it was done last spring. He introduced 6 modules that if we can connect these modules together and have an inflatable one, which you can see with different colors, about beige. And if we can connect these all together, we can have artificial gravity, because we can rotate this one. And like now that astronauts, they're not really I mean, comfortable in the ISS because of the microgravity, maybe this could alleviate the situation, and maybe this could be a test bed for future missions. This is another project was kind of done before that. That is done by Thomas Lagarde. This is one of the very first proposals that SICSA about having a greenhouse in the orbit. And that is basically a plant pot module, plant pot system that they rotate, and they have the red light in the middle, and they rotate, and they plants get even light from the interior, and then it simulates somehow the gravity so that plants, they don't grow in, I don't know, weird directions. And this module is specifically just for greenhouse. And as you can see, for example, on the left side, there is no place for example, workshop or resting of the astronauts. That is specifically, we can call it a agriculture lab, as designed for the growing plants. This is done by Susanna Bianco. This is one of the very interesting projects at SICSA, because it is introducing new Venice. That if we have a space station over there, and if we want to expand it to somehow reach to the level that we can have enough people that we can call it a city, would it really look like a Venice, which is floating, but instead of water, it would be in the space? So how these modules can connect together, and how people can move from one of them to the other one, and how, for example, as you can see on the left side, how the spaceship can dock. This is one of the very famous projects that SICSA for the storytelling, that if human wants to really have a settlement in the orbit, how this can happen, and how we can have the experience that we have in Venice in the orbit. This is one of the very extraordinary proposals at SICSA, that we call it sustainable space station, or as Leo Guzman, who's who has proposed this idea, has named it Payload Shroud as space station. As everyone is familiar, that if you can see it here, every time that we launch something to ISS, the payload shroud, this part which is holding the actual module, it just opens up and the module gets into the orbit, and we kind of throw out the payload shroud, and it usually comes back to Earth. It explodes in the orbit and it comes back to Earth. And as you can see on the right side, the actual module that we're really launching to, for example, attach to ISS, comparing that size to the size of the payload shroud, they are very, very different. Here you can see on the lower left that, for example, ISS Columbus module, it has 75 cubic meter of space that you, for example, if you want to launch it with SLS type C, which is 1,134 cubic meter of space. So what exactly he proposed is that instead of throwing these payload shrouds out and just leave them in the space for, I don't know, as a trash or as debris later on, we can really use them, and we can attach them together, and we can turn them into a new space station. Maybe we cannot really use them as, for example, fully pressurized environment, but even if we can use it as semi-pressurized, that could lower the cost of building a space station in the orbit significantly. This doesn't have a sound. So this is done by Albert Rajkumar, which is gravity simulation platform for the orbit, that if we can launch two, oh my God, I forgot that. SpaceX module, Dragon module, and we can attach it to the gravity simulation platform like this. We have two of them together, and then we have the actual module that controls these two Dragons. We can start simulating, and we can test what, for example, the gravity on Mars can look like, and we can test it for long time missions. That, for example, in here, that is a 30-minute mock-up, and those two modules start spinning, and then they get farther apart from each other. They are attached to the main module with a tether, and they start spinning. We can almost generate any kind of gravity that we want. Because we don't want to harm ISS, so it detached from ISS, does the simulation, and it comes back. So this is one of the very innovative projects at SICSA too. This is done by Tamali Basu. She started this project when she was doing her internship at MIT Media Lab. The main purpose of this is called Astropod, which is, for example, when the astronauts especially in orbit, which is very tight in ISS, and they don't really have a private section for themselves to separate them mentally from, for example, the working environment that they have, and they want to connect with their families or with the people on Earth, and they don't want to be disturbed, and they just want to have their own private time. This astropod can help them. It is basically made of fabric and the very minimal structure that on the right side you can see that it has a projector, that projector shows the 360 image of the environment of, for example, of whoever they're talking to with video chat on the astropod. And then this gives kind of a live interaction, and maybe I mean, comparing that to, for example, talking to someone with computer, laptop, or even, for example, phones or tablets. This is a very larger screen, and this kind of secludes the person who's talking, and hopefully can give that privacy and that kind of joy of that environment for a very short time to the astronauts. This is done by Justin Lee, and SICSA has students from different backgrounds. So previous project that you saw is mostly done by the students that they had architecture background, and that was the reason it has all designing and renders and so on. But for example, Justin had background in aerospace, and he was really interested in solving a problem that we have currently in orbit for ISS. And he proposed active protection system for ISS, which means that, for example, now when they want to detect a debris, like past couple of days that a debris hit in Canada Arm and it caused some problem, if we can have a system that has active protection, and we can have, for example, as Justin was proposing, a laser that can detect debris around couple of from 3 to 5 centimeters to around 45 centimeters. With this method, we can prevent the accidents like what happened a couple of days ago. And this is basically a device that's on the lower right. You can see it can be attached easily at the center of ISS or any part that they think that it is more necessary, and that could start scanning. And as you can see on the right top, it has dual laser and dual scanning that can cover almost 35 degrees of around the ISS. So that can really cause reduce the unwanted damage to the ISS. And this is one of the proposals that all the judges that were thinking that would be very, very beneficial if they can really develop this idea and use it later on. So we have interesting moon. This is one of the very most recent proposals at SICSA, which is done by Vittorio Netti and Pete Morgan and Javier Lopez, which they proposed a multiple purpose utility vehicle, which was one of the winners of RASCA NASA's competition. Basically, when the proposal was based on the rovers that NASA previously had, but they tried to add some features to the previous rovers, and then make them more compatible with for the EVA. So because most of the rovers that we have at NASA, like Athlete, they were designed to work autonomously, and they're not for human integrated mission. So this is one of the proposal that was really, really interesting. That as you can see in the picture, when the astronaut they're wearing their EVA suit, they're not really mobile, and their movement is really restricted. So they can use these arms to move around. And as you can see here, it's a white part on the in front of the rover that is like a not like a Canada arm that big. It is a smaller arm that can do the drilling. It can excavate. It can do multiple um, jobs that the astronauts with EVA want to do, but because of the restrictions of the suit, they cannot really perform it well. And as probably you have seen lots of videos of Apollo mission that they want to dig the ground, and accident happen, they fall down, and they cannot really do what they were planning on. So this hopefully can be one of the solutions to that problem. That it is not everything should not be done by human to be perfect. It can be partly done by robots while human are controlling it, and that could be very perfect, and that could harm less to the crew. This is one of the kind of not old one, but that is one of the most inspiring concepts at SICSA, hyperinflatables. The whole idea is that, for example, if we want to launch a normal hard shell module, as we were talking about Leo's project, that payload shroud has limits. So if we want to launch anything, it cannot be really that big that fits, for example, 4 or 6 crew to call it a habitat. It would be very, very small. So the solution for that in this project is having a hyper or exoskeleton that can kind of merge by the environment, which means that the skeleton and the inflatable, both of them are interactive with the environment. That when, for example, on the left side, you can see how it folds and compacts to fit into the payload shroud. But when it reaches the surface, it inflates like a balloon, and it shapes with the topography of the environment. It sits on the floor like, and it shapes like the clay that it doesn't make any, as you can see, and if we have something like spherical shape, it really cannot be very stable on the surface of the moon, especially with the moonquakes that we have in different regions. So if we can have the manipulated volume, which is more flexible towards the environment, that might be a good solution towards the designs. This is one of the very old, not old, but one of the very inspiring SICSA project, which is done by 2012 by a group of students, which is about lunar settlement planning. So when we were talking about lunar habitat, like previous project, we're just talking about just one module. But if we want to move further, like Artemis maybe 20 or 30 something, we really want to have the settlement planning, and how these modules are connecting together, that might be a very, very huge problem to be solved. So in this project, these beige toruses, they are inflatable module, and the gray horizontal modules are the hard shell ones. And how these are collaborating together is that the hard shell ones are going horizontally to connect all the modules together, but the actual place that people are going to live and spend their most of the time, because it is bigger and it has more space to have the actual feeling of the habitat, are the inflatables. And because probably you have heard it that if we want to really have a settlement on the moon, it should be close to the environment that has more water. And those are really, they're mostly around the Shackleton crater, which is the south pole of the moon. And they're in a very dark environment that, and they're in the edge of the craters. So how we can solve that steep craters environment, and how we can design a settlement and a planning that can move towards that topography to make it more feasible to go up and down and still be close to the water and still use the ISRU ISRU, oh my God, um, uh, facilities. It is very, very critical. So this is one of the very important proposals at SICSA. Mars, which is the fantasy of most of the people. I mean, at SICSA, people are orbit people, moon or lunar people, and Mars people, and we have some ideas about the other planets. But Mars is one of the very interesting regions. This is one of the very nice presented and very thoughtful projects at SICSA. You will enjoy this very much. This is really, I mean, inspiring projects since 2013 for almost all of the SICSA students. So you enjoyed it. We have another video which is done by SICSA student, a group of students, which is you'll find it very interesting because this was done around 2010, and that was really pioneer at that time comparing to the recent concepts that we have now. So this doesn't have the audio. This is the lander, which is holding the actual horizontal module. And as you can see, slowly puts it underground. The same method, almost the same method that we had the lander for the Mars recently. And you can see tiny legs are coming down. They have wheels. So instead of just having a habitat or having a module that can be that we have it as a settlement in just one place, because it is on the wheel, we can somehow carry it like a caravan or something like that around the Mars till we find the actual place that we can have the settlement. So you can see it is being pulled because there are a couple of other modules that they're going to launch together, and it is going to be pulled or attached to other modules to, I mean, not get very separately distanced together. And the astronaut is walking with the module. Yeah, so they connect together through the docks, though, inflatable docks. And then when we really have found the very perfect spots, as you can see, we can slowly have that settlement. And as you can see, there are two horizontal hardshare modules, and that white part is the inflatable one that you can see it grow, that it can provide the actual living environment for the crew. And we can use those horizontal modules as lab and as other facilities. This is done by Canon Martin in 2016. The name of the project is Ansal Habit, or the Shield of the Mars. This is one of the very interesting projects, which is about 3D printing of Mars. And basically, as you can see on the right side, it has a hard shell, tiny hard shell module underneath, and then it has an inflatable on top. And then there is the 3D printing structure outside, which is protecting the whole combination of the modules from the dust that is going to be on the Mars, and plus the radiation shielding, which is what we really need. On the left side, you can see that there are some holes in the structure that they're putting some kind of glass on top of it. There are some concept that we can, if the technology is you can if the technology is moved forward that good and that fast until we when we have the 3D printing technology, we can have the 3D printed water or a combination of water with silicone on Mars, that we can print something like glass on Mars that we can attach to the actual 3D printed structure, that we can bring the light in with those, and simultaneously we can have the radiation shielding. That might be a good idea, and that which was proposed in this. I think this was proposed even before the Mars Ice House, and that was one of the very interesting ideas. That small white module that you can see on the left side, that is one of the ESA's module named She. So this is comparing this module to the ones that NASA has, that has, She has more compatibility towards the having inflatable on top and towards the size of the module that we can really launch it. This is a little bit bigger than what we have at NASA. This is another project by him, and this is one of the wonderful projects too. On top left, you can see he has proposed connection component. What do we mean? If you recall, when I was showing the moon planning and the horizontal and vertical connections between the module, that is one of the struggles that we're going to have if we want to have multiple habitats attaching together. So he has proposed the connection component, which are foldable, they can be open, and they can start kind of pulling and attaching different modules horizontally and vertically simultaneously together. You can see in the middle that one of them is open and the other one is closed, and they are on some kind of a leg or pedestal that we can adjust it to the height that we want to really use it. On the right side, you can see in here that there is, somehow we can call it in the second floor, that we have those connection modules, and they're preparing the actual hubs for the other modules to get connected together. So at the end, if we have all the modules together, as you can see on lower left, it's going to be 2-story hard shell modules, and the third floor, it's going to be the inflatable. And these have different and these are in different categories. Some of them are just habitats. The other ones are for example, for labs, for greenhouses, and for different purposes. On the lower right, you can see how it is expanded and it is shaping the base. The one good thing about this idea is that when we make these structures compact on Mars, it is protecting them. It is protecting the interior environment between those modules from the sand dust, and it is preventing it from absorbing sand dust in the middle, which means that, for example, if it is open, and if we, for example, have sand dust for years and years, it is going to feel that spot. But if we kind of make them very compact, this is not going to happen. And another good proposal for this is that when you make it very compact, uh, managing, or for example, in the actual architectural planning, the urban planning of that, that would be easier to control that. For example, if anything environmental is going to happen, if we are going to have some kind of quakes, if we're going to have some hazardous around, controlling that environment would be easier comparing to a very vast urban planning on Mars. One of the things that we have here are solar panels. As you can see, this was done around 2016. There are still some arguments about having solar panels on Mars or not, but that was one of the very early concepts at SICSA, which was complete urban planning or complete settlement with all the facilities, infrastructures, habitats, and all kind of modules. And this is, I was checking his profile yesterday. He has done lots of interesting projects for NASA. And if you check his website, canonmartin.com, you can see lots of development that he has done after this project. But it was after SICSA, but and I couldn't put it here, but you'll be fascinated with his designs and drawings. One thing that we have at SICSA is that we work on commonality and human system integration at the same time. So it's not just about designing habitats for Mars, Moon, or the orbit. It could be another type of idea too. This project, the multi-mission extravehicle robot, which it's somehow followed by the other, the Rascal project that I was showing you previously. This was done by Vittorio Netti too. And the idea is the previous one was for surface missions, the astronaut for the EVA, he was standing on the robot and he was exploring around. This is proposed specifically for the orbit, that it has a service module, it has tools for the arms, and it has the actual arms, which enables the crew, instead of, for example, taking risky acts in the orbit, or if they want to do something very specifically, which again, it is limiting their movement and they cannot, for example, screw or unscrew something in the orbit, these arms can, which is controlled by the crew over there, that could help them to do the job faster and more accurate. And as you can see on the left, there are different tools that are designed to be on these arms. And one of the things that makes this design very significant is that he didn't propose a new arm, that new tools to attach to the arm. He is saying that if we want to have this in the orbit as fast as possible, and we want to enable international collaboration on this, so that for example, if the European module or if the Japanese module needs some kind of tool that it is specifically for them, just by having the arm for that tool is enough. That just by inserting that part to the actual arms, everything can be fixed and it doesn't need complicated adjustment. These could be outsourced from different places, and it can be really easily adjusted to the actual in the multi-mission extravehicle robot. This is one of the very fascinating projects that is common habitat for partial and microgravity. So there are lots of studies at different NASA centers that, for example, if we really want to work on some kind of a module, doesn't matter if it's a inflatable or if it's hard shell, anything. Can we have it? Can we have something that works perfect in the orbit, and meantime it works perfect on the surface of the Moon and Mars too? So this study was done by Paula Gonzalez Marquez, and she studied what should change if we want to, for example, put a module on surface and put the other one in the orbit. you can see on the left side and on the right side, if you compare these together on the right side, for example, the position of the person who, for example, wants to open a closet, in a box or something like that, the position of his body, his arm is way different than comparing to the left side, which someone is standing and is reaching to open that door. And for example, when you compare the person who's sitting by the table on the right side and to the one on the left side, you can see, for example, on the right side, you really don't need a chair or anything that you can lean on, just as much as space that you can put your feet around something that you can fix yourself, or you can connect yourself to the table. That would be enough in the orbit. But on the other side, as you can see in the left picture, if on the surface of the moon or Mars, we want to sit by the table to have, for example, a dinner or lunch, we really need that chair to sit on. It is not going to be the floating situation. This project was done in a full year study, and they have published multiple papers about it. And you can connect to Paula about it. This is one of the very interesting work that has been done in commonality of the habitats. Most interesting part, which is somehow lots of people are curious about, is that, okay, what else? So what we can have on the other part of the solar system. This project was done in 2017 by Taylor Phillips, and this one was proposed for outpost for Venus. And you can see on the left side, I selected a part of the mission architecture scenario that he was proposing, that we can have a skyline descent and aerobaking and then braking, and then we can have the payload coming out of it with the parachute, and then we can launch we can bring the parachute in the atmosphere of Venus. Meanwhile, when it's getting into the lower part of the atmosphere, the module it is folded, so the module can open up, connect together, and have the actual something like a airplane or something like an drone. And then the inflatable part, which is the one that you can see in blue and white, it starts inflating and popping up. So before that, for example, the crew are just in the gray area of the spaceship, and somehow the space is very tight and it's probably not comfortable for long duration missions. And then they have the inflatable, which is going to turn into the actual habitat space, and they can have their greenhouse space over there, and they can start, I mean, they're very small settlements in the atmosphere of the Venus, because as you know, we cannot really, I mean, landing on the Venus is not going to be very useful. So this was designed for floating in the air. And the last one, which is one of the interesting projects too, is a parametric propulsion using for Titan's condition. On the right side, you can see the exterior of this spaceship, and the left, you can see the interior part. So Zane Koida, he proposed this idea that if we can have a parametric exterior that, as you can see, it has holes and parametric holes for thrust point and for suction points. This shape that he's proposing can be very efficient on the atmosphere of Titan, and even for the landing part. And as you can see on the left, it is not designed to hold lots of crew. It's just designed for having 2 crews and for surface missions, and basically for short missions to just have the excavation. It has suit pores. They can go outside, do their mission, and then they can come back. But because the mission is very far, and having the very efficient shape that we can really bring that module to the Titan without any problem. That was his goal, to solve and to direct. And these were almost the most recent. I'll try to put the most recent projects here. SICSA project, you can see one of the very famous designs of SICSA in here. So I encourage everyone to check SICSA website, and you can ask me any question about SICSA projects. And if you have any question about applying and anything, you can ask me or Dr. Olgabanova, the director of the program. Or if you want to ask any question about the projects that I show you, you can send email to the designer of the project, or you can send an email to me and we can answer you. Thank you.
Well, thank you very much. So I think, Masa, we have probably a lot of questions to go through. What I'll go ahead and do is go ahead and take away the co-host for most of the people so that you can put your hands up. And Masa, I guess I'll let you kind of call on the people in the chat room as you see fit that way.
Yeah, Barbara, can you hear me?
Yes.
Sure.
I have two questions. One, when I noticed your round trip to Mars, you felt that you had to carry a heavy crew capsule back to do reentry. We have ISS, right? So why would we not just dock and let Dragon come up and pick them up like they do any other astronauts? You know what I'm saying? All that extra heat shielding to bring the capsule back down on Earth seems like a big waste.
This one you're talking about?
No, the one to Phobos.
This one?
No, your round trip. So you had a year-long round trip, year and a half long round.
Okay. Yes,
yeah,
yes.
And I noticed you dropped the capsule in, had a heat shield capsule that you dropped into Earth atmosphere, and that struck me as absolutely bizarre. Yeah, this one, right?
I guess it is this one. Yeah. So one thing is that this was done 9 years ago.
Before Dragon, right?
So, yeah, there was no Dragon at that time. Yes.
So one would not do this now. The other question I had is I see all of this stuff is on the surface, and back when I was looking at this out at Caltech in the 70s, most thinking was that we do it underground, that we simply wouldn't need it. It solves a whole lot of problems, everything from dust to shielding, right? And we do know there's lava tubes both places. Now we don't know that lava tubes and ice are in the same spot, right? But still, so is underground just out of thinking now because of 3D printing and stuff, where people think it's just easier to pop surface modules up?
No, actually, there was a long discussion about this at SICSA. So one of the reasons is that NASA is really against the lava tubes, and they have their own good reasons. Number one is that we have no idea what is inside of the lava tubes. I mean, we don't have any launches or any robots that they have gone into there, and they have, for example, 3D scanned the environment, and they have make sure that, okay, that is a good environment to, for example, put the inflatable inside, and instead of 3D printing, just we have a natural shield. Number two is that most of the sites that NASA has considered as a landing site, they have seismic activities. So if we have seismic activity, and meanwhile we have settlement inside of the lava tubes, that might cause a huge problem, and that could bury them inside of them. So this is one of the things that, I mean, on the other side, ESA is on the other, side of this argument. And I worked for a couple of days with people at SpaceBit that they want to launch basically some kind of spider robots that they're going to send into lunar lava tubes, and they want to have some kind of 3D scan of the environment and to see if those environment, for example, the bed of those environment, is that flat enough, is it harsh and it's going to penetrate the inflatable, how are the flat bed of that environment. And the huge problem that they are facing is that most of the robots that they want to launch, that for example in this case in that spider robots, they're mainly powered by solar panels, and when you see the robots inside of lava tubes, there is no light. So the maximum distance that those robots can get in is something like 20 meters, and that is not enough for having enough information about a lava tube.
So are you saying that the surface structures are quake proof? And to what level are they quake proof? 5, 6, 7? I'm just curious. I don't know that we know what magnitude of quakes we could encounter on either the moon or Mars, right?
Yeah,
So
we don't have much information about that. There are a couple of satellites orbiting moon that they have produced a map of quakes, which is not really accurate because yeah, we had a project with a company named Searchbot, and we were designing for Shackleton crater in lunar South Pole, and wanted some information to make sure that what we're proposing for NASA has accurate information, but we couldn't find anything. We contacted everyone and they told us we don't have any information. And I think one of the missions of future missions of NASA is sending robots with lots of sensors into Shackleton crater to make sure that, for example, number one, the estimated water that we have now is that accurate to make sure that that zone that everybody is talking about has enough water. And number two, the sensors can measure the seismic activities and tell us that, for example, if moonquake is happening, how much is that activity? And if the meteoroid is hitting that ground, how much is that one? Because that is one of the regions that has lots of meteoroids effects, and that is one of the considerations for, shielding the habitats too.
Exactly. Yeah, that's interesting. I guess it depends on also you're thinking about level of risk. I mean, popping them into lava tubes is quicker and higher risk, basically. Which was the thinking back in the 70s when people were pioneers and not sissies. And now that NASA has lost people, it may turn out that the US can't do this because the risk is still too high, and you have to launch from Russia or China because they don't care.
Yes. So there are two sides. Some agree, some don't agree. So I don't know. Gary, please ask your question.
I just wanted to say really quickly to Barbara, one of the current SICSA students, he is, for his master's thesis topic is about lava tubes. So maybe we can hear more about that in the future. So more to come. He's not on right now, but.
Thank you, Simone, for mentioning that.
Yeah, sure thing.
Gary, go on.
Okay, yeah, thanks. Great presentation, really interesting different projects you guys have got going on. My question has to do with living systems theory. I'm wondering if SICSA has ever looked at, this is the James Greer Miller theory of categories of functions of living systems. So it's a functional analysis of living systems. Have you guys used that at all?
Yes, we have several projects on that too. Basically my thesis was about integration of greenhouse module to the habitat, just the systems part, not the design part. So, I was thinking maybe just showing some kind of diagram would not be that interesting for this presentation, but yes, there are lots of projects going on around that part because part, as I said, just some people who attend at SICSA, they have architecture background. Most of them, they are mechanical engineers, aerospace, physics, math even, and based on their interest, they have picked different aspects of the projects. And yes, we have several, I think we have more than 10 different proposals, even for launching and landing systems at SICSA, that how that can improve and how, for example, that can integrate with different orbits that can lower the cost of launching.
Yeah, okay, thank you.
Sure.
I have a question.
Sure.
Okay, yeah. First of all, I enjoyed the presentation, and secondly, I was wondering if SpaceX was involved in a similar habitat and architectural program, and if you're working with them in any way.
That is one of the mysterious questions, because most of the SICSA graduates and space architects around the world, we are at the Space Architecture Technical Committee of AIAA, as Greg was mentioning. I'm a part of them, but no one from SpaceX has ever entered that committee, or we have no information that who is working there and is in charge of the architecture part. So that is still mysterious to us, that who's doing their habitat, or if there is any habitat over there, because we were thinking for a while that maybe that's just bluffing and there's no one really working on habitat for them. So as far as we know, number one, we do not have any information about who's working on it. Number two, maybe it is not their focus for now, and that would be so. For example, lots of previous SICSA graduate, and I mean the head of the space architecture field, they're working for Blue Origin or Northrop Grumman or Axiom, and they're really working on habitat modules, but we have not heard about SpaceX at all.
Thank you.
Sure, you're welcome. Any other questions?
Well, we've had some questions come in through the chat room. One was about how to apply for the program. So maybe you could talk about your experiences in terms of how you found out about the program, what attracted you to it, and then what the application process is like.
It is not that complicated. It's just like applying for any other programs. The only thing is that because this space architecture is interdisciplinary field, whatever background you have, you need to have a proof that you have studied something about space and you have done something about space. That could be a project that you have done in your undergrad or in your master's, or you have participated in competition, you have published papers, any kind of activities that you have done could go on your resume. And then it could be, I mean, that would be very helpful, because most of the time that those people that they do not have any idea about space architecture, even if they end up getting accepted at space architecture, they drop out after the second or third week, because they say that this is not what we were thinking. That is really, that is something that you need to think about it before you apply. So if anyone wants to apply for that, just checking. We have lots of events. I mean, I think we have at least 1 or 2 events every week about space architecture around the world. Especially, we have International Space University in Europe, which is not exactly what we do here, but they are trying to follow on their own path. So listening or watching the meetings, the videos from space architecture here, or from them, or from SATC, Space Architecture Technical Committee, that could help them to have better vision what exactly is this program about. If you're interested, for example, in the systems design, if you're interested in the architecture part, the design part, anything that you could be interested, there is a place for that, but you need to know your passion before entering the program.
Okay, and also John put a couple of questions in there. John, did you want to go ahead and just ask those questions?
Yes, thank you.
Sure.
You know, there's a contract for a nuclear rocket design, and it's going to be funded beginning October 1st. So it's going to be twice as fast as the chemical design, and probably we'll use it to go to Mars. So first thing is, you had a very interesting video, but you're probably going to have those time frames next time you show it, or you might indicate it. It might be used with a nuclear rocket engine. Another issue is we talk about applications with nuclear processes, and one of them we discovered was to use radioactive fuel and the actual carbon atmosphere of Mars. So we're trying to create a backpack that will create an atmosphere, a breathable atmosphere for humans, using the actual atmosphere of Mars mixed with the radioactive fuel. Have you ever heard of that, or?
Yes, I mean, so like lava tubes, using different types of energy sources that might cause some hazardous environment. It is one of the concerns at SICSA too, that for example, if you're using nuclear reactor, if you're using bioreactor or anything like that, what if it goes wrong? How you can protect the life of that crew, or how you can protect the habitat from, I don't know, spreading a contagious gas or disease or anything like that. So for example, as far as I know from NASA standards, if for example you want to provide a nuclear reactor as the power source of your habitat, that should be around 10 kilometers away from the habitat. And that is I mean, that affects the planning part that I was talking, that is very, very important. And so we really consider that for example, in the past couple of years, almost everybody who's designing at SICSA for Mars, they know that they should not include solar panels, because solar panels are not affected, and we really need another kind of source of power. But what we really, I mean, you can see different proposals and different projects, but we really have no standards till now, because we're trying to follow up what NASA is saying, and NASA's regulations are that. So it is yes and no. Yes, we considered that, but no, we really do not have any final results or solution for that how we can integrate it to, for example, if we assume that something is happening in that reactor, it means that you should go from your habitat 10 kilometers away to fix it, which means that with the current speed of the rover that we have, you're on your way for about a day and a half to fix it and then come back. And that would not be efficient. So what is going to happen in the middle in those 3 days, or at least in that day and a half, or maybe in some cases that the rovers are just using solar energy in about 2 days. So yeah, I don't have a very exact answer for that, but yeah, we talk about it a lot.
One thing though, this has been approved by the Defense Advanced Research Projects Agency, so they probably have more of a trust in the system, the nuclear rocket engine being designed. Certainly NASA has tremendous amounts of experience with chemical rocket engine. So, but you know, we still have to work in. Okay, let's reverse the question. What energy system are you proposing for your habitat?
Well, I can answer the first part of your question first. That, as I mentioned, NASA is one of the sponsors of the program, and at the very first semester, we have courses that we learn NASA standards. So whatever we're designing, because it is sponsored by NASA and most people are working at JSC, so it is a must to follow NASA standards. So even if, for example, in this case, Japan has accepted that method or idea, uh, it is okay to propose it in your project, but people are not that optimistic about the whole idea because it is not towards that. And yeah, and the second part, yes, almost everybody is proposing the nuclear reactor or bioreactor, as I mentioned before, but um, because SICSA is not that program that, for example, you actually design that reactor. We just assume that in the system we have a reactor that is providing the power. We don't get deep into how that reactor works, how much power is giving us. We get those informations from NASA or ESA with their annual or monthly report that they produce.
Thank you. Thank you.
So one reactor you should take a look at is a company called Ultra Safe Nuclear Corporation, USNC. They're developing a very small, like human scale size reactor for Canadian Arctic mining operations, and they're designing it specifically with the operation on Mars and in space in mind.
We have a course at SICSA almost every semester that is basically seminars of different speakers. For example, about the nuclear, we had lots of guests that from different companies. Before COVID, they came over, or we had a video chat that they introduced their product. That hey, we have done this, and this is the future that we think can happen with our product. We want to know what exactly you think or how you can integrate the systems that you have to our product. That, for example, I remember that at least every semester there is one or two company that they offer a collaboration that, hey, we can, for example, pay tuition of some students or help in the scholarship if you can have a project that can integrate this part of our product to your design. We have this kind of collaboration at SICSA, and yes, we had different factories that they were proposing. I mean, different kinds of power source, and we have worked on that. But if they want, they can connect to SICSA and they can start collaboration. Yeah.
Okay. So are you still actively involved with the center?
It's COVID, so we really don't go over there. We just participate in the gatherings and everything. I used to be Dr. Banova's research assistant, and I'm still working with her on different papers. So I'm somehow involved and not involved at the same time. But yeah, I told her that I'm going to do this, and she said, yeah, you know the best. You're almost the only person in the SICSA that I dug deep into every project because of the systems that I was looking for, and that was the reason I'm presenting the projects today.
Yeah. Is Larry Toop still working with you there?
Yes, he is one of the wonderful professors over there. He is amazing. You learned a lot from Larry Toops. I mean, every 10 minutes that he talks is just a one perfect advice for your life or your design.
Yeah, that's Larry. Yeah, I worked with him when he was bringing the students over from Lund University back at JSC, 2000s, early 2000s.
Yeah, he is an amazing professor. He's the best.
Well, thank you so much for presenting. And I guess what's the best way for people to stay in, contact with what's going over at SICSA?
We have Facebook page, which is very active. You can subscribe to SICSA newsletter. You can subscribe, go to spacearchitect.org. You can subscribe to newsletters over there. And what else? The Facebook is the most active one. I mean, you can see all the events, any Zoom meetings, anything, or any book is published, you can see them over in the Facebook page. Yeah.
Well, sounds good. Well, I really, it's really great to hear this. It sounds like we might have another question. David, were you about to say something?
Yeah, sorry, my internet connection was dropping there. But I was going to say one thing that might be of interest for the program. There was an effort by NASA, one of my former colleagues or good friends there, to do a crowdsourcing program on ISS recycling. That was originally the idea was what to do with the ISS after it becomes decommissioned, end of life. Are there ways to recycle it as a whole, or in parts, or in modules, or down to the raw materials? I think they've renamed that program now Spacecraft Recycling, but it was kind of really intended to address the ISS. So that may be something that would be of interest for a project over there.
We had a project about it 2 years ago. It was my first semester over there. That there was a company that they were saying that we're negotiating with different organizations and everyone, and we want to buy one of the modules and turn it into a somehow very luxury honeymoon suite or something like that. And we want you to redesign the interior and give us a proposal that if we like renovating architecture, if we want to renovate that module, how would that look like, and how we can really have that luxurious feeling over there. Yeah, so there are some companies that they are really looking after buying this modules and turning into something else. Yeah, it is an interesting field.
Yeah, well, there's been a number of those. This particular one is a crowdsourcing, NASA at Work crowdsourcing prize challenge competition, whatever. So you might look for it to be announced shortly.
Right, sure, I'll check it. Any other questions?
Well, I had a question for the audience. At the Barbara Bush Library, where we used to meet in person, actually is open at a limited capacity starting a couple of weeks ago. So I have a question for the audience. I'll go ahead and launch a poll. But if we were to meet in July, would you have an interest in actually being there in person? Or, if we did meet in person, we would still have the virtual option. But I just kind of wanted to get a feel for how people might think about that. I'm personally kind of excited about the possibility of getting things back to normal. And anybody have any thoughts on meeting up in person? Should we require everybody to wear masks? Should we space out the chairs? Should we limit the number of people that could sit in the room to a certain number? Any thoughts along those lines? Maybe speak up or put something in the chat.
Yeah, maybe you have policies related to whether people have had their vaccinations or not. Like the grocery here that I go to has a sign up that says if you've had both of your vaccinations and it's been, the requisite time since then, it's not required.
What is the policy at Barbara Bush?
I'll have to check on that. I was just looking at their website today to see if when they were going to open back up, and I was surprised to see they already had, but I didn't get a chance to look into it much more. But I'll reach out to the librarian and check on what their policies are. It might be a moot point. They might be very specific about how the meeting's conducted.
Yeah, or if it's not required, encourage at least, to wear it. Could be another way to do that.
Well, it looks like we have 5 people that could attend in person and 6 people that would attend virtually. So that's good. And I think we could still have it as quote unquote virtual meeting with just like kind of like a co-hosting option for those who want to watch it together, kind of ease back into the
Yeah, it's
situation.
kind of nice having it virtual because then you can extend the reach further than people would really want to drive for it or be able to even drive for it.
Yeah, Tom Hessen, for example, is joining us from Columbus, Ohio.
Well, I'm glad to see you, Tom. I am working on my pilot's license, so maybe I could come swing by and pick you up and drop you off.
And I'm back up in Wisconsin again. So if I happen to be down there early in the month, I would love to pop over, but I'm not always there. So I love the virtual option.
We can make it hybrid. If we go over there, we can still have the video of it, and those people who cannot be at the library, they can see it.
Yeah.
Yeah,
I
since
think
we're talking about the people who are outside, we have Elif Kiva here. She is one of the future SICSA students. She is in Turkey now, and she has joined us from there. I'm really happy that we're having her here. And one of the things that anyone who wants to apply for SICSA is that there's no funding, there's no scholarship, nothing. So you need to pay everything for yourself and the cost of living. So that is a huge problem for SICSA students. And we'll really encourage if there is funding from any company to, I mean, as I was saying, the collaborations can bring some money for the students, and that would be a very good opportunity for people like me, Elif, and lots of other people that are struggling with the financial situations that they're coming from Middle East.
Nathan, can you control a Zoom virtual meeting from a laptop at Barbara Bush?
Yeah, we can. I think what I would probably do is have somebody virtually responsible for the virtual meeting and collaborating with the participants, and then have a person in the room that's just taking care of that interface between the live event and the virtual event, just so that we could kind of keep from getting bogged down in either group, and both groups feel like they're first class participants.
Yeah, we're planning.
It's actually much more work to do both at the same time.
Absolutely, but I think there's still a lot of benefits to meeting in person, because you could sometimes attract people that are just walking by. You have like side conversations that are a little easier to have than virtually, and yeah.
Well, we are definitely planning the Space Settlement Design Competition Internationals at Kennedy Space Center this year to be hybrid dual mode. So we will end up with a lot of experience, I think, on running these in that hybrid mode this year.
Well, and whoever's running that, maybe they come give us lessons or volunteer to help us sorted
Well,
out.
well, I've been running the virtual platform for it pretty much, which that's the Discord that you've been on that emerged from doing that. And that, by the way, that allowed a lot of that personal interaction that is really kind of difficult to do just with Zoom.
Nathan, we're going to do the AIA symposium in October as a hybrid. So we'll be very close to that magic 70% vaccinated number.
That'll be good.
So,
Well,
but you need to check Barbara Bush what their rules are.
absolutely. Absolutely. Well, we're coming up to the last few minutes. Does anybody have any space-related stories or personal events they wanted to share? Maybe you saw something in the news that really touched you that you want to share, or
I do have an item.
oh yes, tell us, Vito.
Okay, well, on Rice University has an open stack. Hold on, let me check the volume here. Rice University has an OpenStax program whereby you can get free literature, and I got a 100-odd page astronomy book from them free online. The pay version, the print version is available on Amazon for a fee, but you can get the free version online, and it's for anyone who wants to have like a compendium of astronomy and related information and space exploration. It's a very good book, and I can send a link to you about it later.
Oh, that'd be great. Yeah, I'll add it to the notes for the meeting so that people can look into that. That sounds like a good additional resource.
I can add SICSA library too. I think in total SICSA library, the PDF files you can download from SICSA website, it should be more than 3,000 pages of just SICSA space architecture projects and related stuff that people can, if they just want to get familiar with the whole program and what was the past and what is going on now, and maybe some kind of future ideas, they can really check those PDF files. They're really, really useful.
Well, that sounds good. If
Yeah,
you have the
where is that available?
Let me show you very quickly. Let me share my screen. So this is SICSA website. In here you have library, and you can have SICSA lecture series. These are all the courses that used to taught at SICSA, or they're still being taught at SICSA. You can download all of these and you can read them. Plus there are publications and report, very popular or very famous papers. You can find them here, or very significant projects. You can find them here. And in the projects, you can see more videos about different projects at SICSA here, and you can see the PDF files of some of the recent projects in here too. I didn't show all of the projects. I just tried to select most relevant or most interesting projects here, but you can see them all in here.
Okay, thanks.
Sure.
So, Nathan, one thing I was going to mention was, I don't know if you saw that National Space Society nominated the Falcon 9 and Dragon 2 for the 2020 Collier Trophy Award. Did you happen to run across that one?
Yeah, I think I saw it briefly. I'm not familiar with the Collier Trophy. Maybe you could talk a little bit about that.
Yeah, well, it's a National Aeronautic Association's award, which is supposed to be for the greatest achievement in aeronautics and astronautics in America with respect to improving the performance, efficiency, and safety of air or space vehicles. the NSS produced a very nice 10-minute video, which was a required part of the submission to put them in for the award. And Bruce Pittman, Dale Scran, Greg Autry, and myself did the Q&A for about 30 minutes with the NAA selection committee back on Wednesday. And sorry to say that they decided that the Garmin Autoland product was selected instead of SpaceX Dragon 2 and Falcon 9. There's an interesting couple of blog posts about that. Dale Scran's got one on the NSS blog site, and Greg Autry has posted a kind of comment about it in his Twitter feed. It appears that out of the 35 selection committee members, only about 5 of them have any experience with space. The rest are all aviation. And out of those 5, Boeing, Lockheed Martin, Northrop Grumman are represented in the selection committee. Reviewing their awards, it appears that only about 25% of the awards over the past 40 years have been for space. So my conclusion is we need to think about space as being not just aerospace as an industry or a discipline, but space development is requiring all industries. So it's really more appropriate as a more human accomplishment award rather than maybe an aviation and space or aerospace award.
Sounds good. Definitely something to consider, because the two have been combined so much, but as we do pure space activities, definitely a whole different ball game.
Yeah. I mean, the Garmin Autoland is a wonderful device. I've seen it at the Mooney Aircraft Factory in one of their new air.
David, I think maybe we lost your connection.
Yeah, he's frozen.
Yeah.
Well, I should mention that our next meeting is actually going to be the second Saturday in July. That first weekend is the July 4th weekend. So we'll actually be meeting next time on July 10th. Still planning to do virtual only, exploring the possibility of maybe doing a hybrid. We'll send out details and put on our website if that materializes. Let's see, David, are you back with us?
Yeah, my internet connection's been pretty spotty. I might be back. I don't know. Looks like it's frozen now again.
We can hear you but not see you. But yeah. Well, David, maybe that would be. We're still looking for some content for the next meeting. I didn't know if you wanted to maybe develop that topic into maybe a 10-15 minute presentation. No, I could follow up with David offline, but anyway, we're right at 4:04, actually a little bit past 4 o'clock. So thank you, Masa, again for presenting. It's amazing to hear about the scope and scale of work that's happening at the University of Houston, at the SICSA school. So thank you again.
Thank you. I mean, for listening. We really like to spread the word around because we're the only one in the world. So the more students that we have, the more enthusiasts we have in the field, it's better for everybody in the field.
Yeah, I think, if we could facilitate more presentations to people at high schools and other colleges in the area, that might be a way to really kind of get more people in tuned and realize that this is actually something they could do.
Exactly, yes.
And Greg, thank you so much for doing the space news again. It was a wonderful overview. I don't know how you're able to keep up with it all and choose what to include and what to exclude, because there's just so much going on.
Yeah, just do the best we can.
Absolutely. Well, thanks everybody. And I think we'll go ahead and wrap it up here. And I'll put the recording on the website tomorrow for anybody that might have liked to have seen it, but couldn't make it today. They'll be able to watch the replay.
Thank you. Have a great weekend, everyone.
Thank you.
Yeah.
Bye.
Bye.